Hello and welcome back to another episode of Gifting Good Oxide. Welcome back, Sid.
Hello, hello.
Yeah, it's pathspec again and maybe one last time. So I guess you can drive it from
If it's the
here.
last time.
Okay, let's make it the last time. Got it. Fuzzing, huh? I mean,
try.
let's start with the most obvious.
Yeah, it was really helpful. Really cool as well. Really easy to set up, and it's basically automatic testing for you, kind of.
Yeah. How many bugs did it find?
Basically two different extra test cases that I had to add,
Yeah.
which is pretty cool.
Yeah. I mean, for now, this means fuzzing must be done for everything we do, and maybe even for the existing stuff that deals with file formats in particular, because it's easy to fuzz, and the fuzzer really gets you somehow.
Yeah.
And relatively quickly, I
Absolutely.
presume, huh? Like, how long did you wait for it?
So this was, I didn't know the you could run it on multiple threads. So this was only on a single one. So it took, I don't know, maybe 10, 15 minutes, not
okay.
super long. But yeah, the
Oh.
7 extra threads did help when I tried it again.
Yeah, I mean, this is just 100 million iterations here, just 100 million input samples. I think, now that I see this, maybe I exaggerated my last number as well, because I thought I had 1 billion, but my execution time was slower, so it was like 40,000 per second only. So maybe I was wrong, but maybe not. I don't know. I always think 1 billion is kind of the bare minimum for fuzzing because it's a nice number that I pull out of my nose literally. Anyway, as long as it finds something, it's good. Yeah, then put some session notes and get through it. To own for name and avoid into. Right.
Yep, that was in the get attributes crate. For the state ref. That was in attributes source lib.
Ah, yeah, here, state ref. But the implementation for that is in mod state.
Should be in the same file, I think.
Yeah. Yeah, I have...
exactly. There's a...
Yes?
Oh, sorry, go ahead.
I have this tendency to... next time I look at this, first I start with these, and then next time I look at this, no matter who does it, right? It's the same with me. Then I just do this because that just gives you a better overview of what's going on.
For sure.
And then
I thought maybe it has to reach a certain line count first before it's allowed to go in its own file.
Yeah, exactly. I thought the same, but then it's like, doesn't matter what line count is, as long as it kind of makes it easier to see, because look at this. You're on the left side now. Now the file structure gives you an overview of what's there, and this is something you don't have if you say create a module only if there's 200 plus lines, for example.
Yeah, true.
Right, and I like it. I like to see here's state, mod state. I can see this immediately, and then I kind of get a good idea of what the structure is. Then I see state, and I know, look into mod state for impulse. Also recently I noticed that you can find usages, and here you also see impulse here. So there's kind of a little bit of structure to that. And yeah, unclassified, I guess that is a bit strange maybe, but it works, so far it works pretty well. This is something I didn't know before, but maybe because it's in a new file and it kind of got confused because of that. Yeah. So both together, I think it's a nice way to organize code. Okay. So now we were, mod name.
Yeah, I think both of these implementations, there are a couple of new things, like the to own that just uses the into, and I think there was one. No, that was the one for name, exactly. and I changed wherever we did use into, it's now to owned.
Mm-hmm.
And I think I had to.
Yeah, you had to,
there was
right?
one more.
Because it's not there anymore. Like name ref,
Yeah.
there's no conversion anymore, so that has to happen.
And then for state, there was something new as well for the state ref, which basically had to implement the custom as ref function to be able to turn a state into a state ref.
Ah, yeah, this compact string again.
Mm-hmm.
That works though. Yeah, cool. And this one, yeah. Every time I choke on this, then I realize, yeah, it must be UTF-8. What can you do?
That is also something I choked on though, because does it have to be UTF-8?
Yes, because of this compact string. I mean, this one doesn't support non-UTF-8. You could use a small thing.
That's not a limitation of the attribute value, is it? That's what I thought. Like, because an attribute value can be or can have other characters in there, I think.
I think it can't, right? Or can it?
Oh, okay.
I mean,
I'm not sure. That's
yeah. It's something to check. So maybe UTF-8 is a requirement. I think the reason I gave it something that expects UTF-8 is that I concluded UTF-8 is okay. And there's nothing else according to specification. So values are somewhat limited in what they can represent. Mm-hmm. And this is why it's okay to do this. But yeah, this also means we have to do these conversions, and we have certain expectations, and it should be fine. But I think every time I choke on it means should be better. Let's check. Let's check real quick, and then improve this expectation, because this ill-formed stuff is too general.
Yeah, so I think I remember in the code that you do check for the attribute names. There's a check for that, the attribute values. So,
check error. Error valid. Where's the value?
There's another place where you use this. Yeah, this one here.
But that's the error name, okay. And now the error value.
Yeah, and the value just gets piped in as bytes.
Oh. That's the state. Yep. There you go. So that's technically wrong then, huh? But is there anything in the specification? So here is the specification, and it really says there's no limits on what this value can be. No encoding, except for a null byte, I presume, because C. But that's it. So this has to go away, and it's probably time for it to do if there is none yet. Yeah, needs binary 2. No, UTF-8 is required for error values. Okay, that's getting longer and longer. But yeah, this makes this correct. No ill-formed UTF-8. Okay. While I'm here. Oh. Okay. Then, what else was there to be fixed? Try to not repeat the attribute name validation logic, but reuse the one from getAttributes.
Yeah, so I don't validate attribute keys, basically, or attribute names. I just validate attribute values, and get attributes doesn't do that, so it doesn't repeat anyway. There's no repeating going on.
True, right. But that's strange. Like, is this like there? It has a requirement for attribute values. All of a sudden.
In pathspec.
Yeah.
Yeah.
So
it's called. I think it's way at the bottom.
Check attribute value. Yeah, this is typical. Oh, sorry. These are the allowed ones. That's interesting, huh? So is there or is there not a requirement for these things? Depends.
Yeah, it depends on where it gets piped in. But from pathspec, this is the requirement. I didn't check the get attributes code in C, but there was there was literally a function that I could pull out that has this requirement here in pathspec.
Yeah, last time I checked, there was no such thing as validation. I think they can't just add that now, because that would possibly break other input, right? So I guess it is what it is. So here there's some validation, otherwise there's none. Okay, fine. Never mind then. There's no name validation logic that you would copy. So, yeah.
Yeah, and the rest was basically the result of the fuzz target, of the fuzz fuzzing test. And basically just an oversight, because I need to check the attribute values, but previously I only checked them when they were being escaped. And that obviously has to happen also if there's no escape character in there. So basically it was a really good example of premature optimization, I think, because I was thinking about performance first and then about all the actual cases that it has to run through. But yeah, and now it does work with all the different cases. And the other one was, if I think the first one is being escaped and the second one not, it would reuse the unescaped input instead of using the escape one. And that's now also fixed.
Yes. Okay. This prefix still there. I forgot why, but we'll get to it. So now, I thought this was an interesting one, because it's very imperative, isn't it? Which is fine.
Yes.
So unescaped, and check add a value. Yeah, I see. This is where that is coming from.
Yeah, it's all a bit tangled up now. It's not necessarily as clear as it was before, but it's still, it keeps the efficiency, I think.
Yeah, I have to be really careful as to not get overboard with the desire for efficiency. It's more like, it's a nice practice here. That's why we do it. But we know mighty well that this thing, you won't notice any performance issues, I guess, because I doubt it gets called a lot. It's really just for inputs. And how often does that happen, huh? It's not too often. Okay. So this one, I thought that's interesting because it could be, we want what? All bytes to be valid. All bytes.
I want the byte.
Let's see if that works. And if they're all valid, then do nothing, or else. But you want the byte. No, I get it. Shit.
And then I tried with find and some sort of map. It was all a little bit too weird, so I thought, okay, a for loop is.
But that's also interesting. Like find the first invalid one, huh? This is what you're doing here, no?
Yeah, exactly. And then the wrong one is in the sum case, and the right one is in the none case, and I have to reverse and turn it into a result. Yeah.
So if we find the first one that isn't valid, I see you kept it very practical and pass references here instead of copying. Fair enough.
Get that into my head anyway.
And now you want this to be the error type. That's why, and you can't really chain that.
Maybe you can. I don't know.
Yeah, but I know the pain. I've been thinking the same thing many times, and it's like, how do you do that? Can you turn this around somehow? So we find an invalid one, and then allows you to use this, and you can pass anything else really. But yeah, we have to uplift it to an option, to a result first, and then it's inverted, and that's probably the problem. Yeah. So I think ultimately with this, it will be better already. Should be. What do you think?
Yeah, sure, definitely.
Yeah. So you've been thinking the same thing, but maybe the reason you didn't come up with this is that you really, really wanted a fully chained version.
Yeah, I didn't even think of this.
And you see, the only difference in my thinking is if it doesn't work, use a match and it's fine. It's okay. All this chaining is nice once you get it. It's like solving a puzzle, but it doesn't always work. So, and that's still, that reads nicely to me. Okay. And now here, yeah, remember we refactored that last time, but now there's validation here, or it feels like there's a
there was before. I just extracted that into its own function, so
yeah.
I can reuse it.
Yeah. So look at this. Now it feels a bit like, yeah, let me try something. It's like if there is a, it's more like transform this byte into an error if it's an error. Otherwise, do nothing. Right? So
yeah, I can tell you why. It's only because in the case that we have to unescape, we already iterate through all the bytes once. And instead of iterating again for checking them for validation.
Yeah. Look, I think you're on a different page. Look, what I had in mind is error if invalid to error if invalid, or invalid error value byte. So now we transform this one. Yes, we still take it as a reference. Do we really want to? Look, here's a double reference. No, it's not a double reference. It's a single reference. So here it wants to have, it likes copies, right? Kind of. Here it likes copies. Here it doesn't. It's just a byte. Let's just go with a copy here, which probably makes it easier. Not here, this one. So the byte should be alphanumeric or not, otherwise it's a result and we have an error. Otherwise, yeah, So since this is a Boolean here, I think it's easiest to just say, okay, if it's valid, do this, otherwise do that. To error if invalid error value.
I think you're missing the error parenthesis, right?
Yes. You catch that before IntelliJ catches it, but the latest version has some sort of, it's not good. It has lots of issues. I think it got worse. But yeah, good to have you here for compensating for the shortcomings of our tooling here. Yeah, now we find the error. Yeah, interesting. Is there a find map? I'm not fully clear on how this will work. But, okay, so this is supposed to return an option now. And I want this option. Might go a bit.
So result, option, result.
Yeah, it's like this option result, right? And that would then just be this. So we find something where this is an okay. So is okay, then we want this. You know, now that I'm thinking about this, yeah, you know, I think there might be a way to really only create this error once with this function. Okay, now I have to use it properly. So using it properly here should be easy. How was it called? To error. Why does it not show up? Because this is
there's an error here. Yeah.
Too broken. Hello. To error of invalid error value. So maybe something like that. I don't say it's great because it's kind of nice to see this if condition so explicitly here, but I guess I'm just playing a bit. Okay. And what if it would return that byte if it's approved? I do that from time to time, that I have these check functions. They consume some input, they check it, and they give it back to you if it's valid. Otherwise, it's gone. You can't use it anymore, and you get an error instead. So it literally is a transformer. So validated error value byte. So you see the function is the same, but now it goes from kind of shitty to fits perfectly here. And now the last issue is just how to get that here in a nice functional manner. And that is still the question. So that's called validated error byte. Find. Yeah, the thing is we also want to keep the error. So it's kind of not super happy about this. Let res be this res Okay, so maybe just match here. Whenever there is problems with the functional approach. So either we have okay, some byte, then we return none because we're not interested in that. Otherwise, we return some error. Look what I'm doing now. I'm now essentially manually implementing. Sorry, say again?
The reversing, basically.
Yeah. Like I want to have the error if it's there, right? So there is, I could use OK to get the OK value, or I could use error to get the error value. Sometimes I'm also a bit, just not getting it. So now we have the error in here if you find something, and now we want to transform that one into an actual error if it's there. So we map this into an error, right? Does this work? We have an OK with an, we have an option with an error in there. Now we have an option result that is an error. I transpose this back. And I think the types don't match somehow, huh?
Transpose makes result option, or does it just switch the, okay.
Yeah, result option. I think the OK type isn't good. That would be my guess. Can I find value B in the scope? Because
it's called byte here,
byte. Mismatch type C. So, there's an option. My bad, I'm sure. Find map. Option error. Option result. Result option.
Yeah, we want to get rid of the option.
Yeah, I mean, you can always flatten things. But that doesn't seem to. Yeah, so the OK type isn't good. Why is that? And we're back on. Whenever you write it out, it becomes more clear what function that could be. Because most of the time this exists, of course. Okay. And we kind of had that last time, didn't we? Like, we want to map this into an error. And yeah, then the none case had the wrong type. That was the problem. We couldn't really do anything about that. But yeah. So that still works. So I prefer this. This is clearly better, I think. Even though that was very suggestive, but I do like it. It's a bit less imperative and kind of gives you an idea of how to do this kind of thing in a readable manner. I like it. It's used elsewhere. I don't know. If you don't like it, it's also okay. Then we can roll it back really, because it's just.
No, I prefer this. This is just as clear as the other one, I think, and shorter.
Yeah, all the meat now goes here, so to say, all the error handling, but you only do it once, so I think there's also something to it. This one here. This is harder to read now, I think.
Definitely is, yeah.
So for byte in input either copied and then we don't care, we can just say validated. So now it doesn't read that good still, even though now it's a bit easier to understand what's going on. And Ah. So close, but that looked, I think that was promising. Output is question mark. Okay, so it really, this must return. That's fair. So the map has to happen here. And interesting. You might want to call that function, that's true.
Oh.
Yeah, so now the map makes it a bit more noisy here, but this could be done imperatively. Like this, I guess. Just to get a different, I think now it's a bit clearer what's going on. I like the formatting more is what I'm trying to say. Now it also works, I presume. Yeah, so that's the little less imperative version of that while using all the new functions. Unfortunately, here we have never any reason to keep the byte, so this is what gives you some trouble here. And so that's another way of getting rid of that type. But Clippy might not like it. Let's see if Clippy is okay with that or not. Probably tells us if we drop a type that doesn't implement drop. And that is overkill or something like that. And it's right. Even though I like to use drop just for that. Calls to mem drop. Wow, it's an error now. Look at this. And it tells us. Oh, interesting. It doesn't tell us what else to do. But yeah, as I said, Clippy does not like that kind of stuff. Fair. So no drop for us. Yeah, well.
I mean, this is clear-ish. It just has a little bit of noise around it, but it's still kind of clear what's going on there.
Yes, it's the issue here is clearly the different requirements, and you can see like this code reuse desire that you have to resist sometimes, I guess, that leads to these things. That code sometimes is specialized, and it shows you more than ever in Rust what it really wants. So I think fn is valid at a value byte. Something that's really useful. And how was this last time? That was for, oh yeah, that was, right. And if I would use that here now, then I have to write the error again, which I also wanted to avoid. For some reason, I think it's not so important to avoid that error. Are we by any chance? No, we are not doing byte iteration anyway. Otherwise, you would have used it here. Okay, fine. I really try hard, right? I try too hard. It's kind of a waste of time. I'm sorry for that. I can hardly argue it's a learning experience. It's just an experience on kind of how not to overdo things. It's good enough. And, it was good enough before. And it's just fine. And now
thinking it could be a little bit better, but
Yes, it's
maybe
time
sometimes
to
it has to be ignored.
it's time to say it's good enough, and it definitely is. What do I do with this one here? Do I just duplicate that? Yeah, why not? So this was a find, I think, huh?
This was in the middle, it was a find, yeah, before that.
I think, or maybe I found it. Maybe I not know now what this is gonna be. So we find something that, oh no, this wants to be in, find something where this is true. No, we need find map again and go down that road. No, I don't want that. No. Find is valid adder byte, not is valid. And then we can match on it again, like it was before.
Yeah.
This. And just do it explicitly again. And there are other options. We had it, but it's kind of a bit less obvious what's going on because of the difference in how this wants to be. Okay, like this. Oh, Clippy is happy. Pathspec is happy. And attributes, are they happy? Yeah, great. Cool. So that's that. I think I added more lines of code in the process, so I can't say I'm proud. It's more like playing around. But yeah, this looks good.
Yeah, I think ultimately, if this function wasn't trying to be efficient in a way that it tries to, to the borrowed version or the owned version, if it just iterates through all the bytes anyway, all of the rest would be a bit easier. And I think that's what Git does as well. It doesn't really make that distinction. It just iterates through all the bytes, checks all of them, and
copies.
Yeah.
Copies all the time. Yeah, ultimately you probably do copy anyway, huh? Like in the end, the output is this somewhere. Right, so in the end, everything is copied.
Yeah, that's actually true.
And this is this one here, huh? So unescape attribute values, because we build a vec of names. So yeah. Maybe this tells us, I mean, you can't really unsee this, right? Like ultimately it's owned, so why bother? And there's no reason to then keep it. And maybe that's also another lesson learned here. What's the final output? So part of the machinery is zero copy and the rest
yeah, exactly.
Not. Right. So okay, back on and everything committed. Yeah, now this means that one here doesn't need to be returning B strings anymore, because here does to owned anyway, huh?
is for the, oh yeah, exactly.
Yeah. So, and this is what? This is a name. Interesting that this iterator, I thought it also provides values, but it doesn't.
How do you mean values? Attribute values?
Yeah, names and values. Huh. But here it looks like it only produces names.
Yeah, this is the type that we named it. So the name is the tuple of attribute name and then the state of the attribute.
Oh, right. Good attribute name, and it's always a name and a value pair.
Mm-hmm.
Phew. Right. I mean, this is also something to think about. I was confused now because look, like attribute name, I think of this and this only, but we also get a state.
Mm-hmm.
It's more like this is the good attribute. Like good attribute.
This is the entire attribute, yeah.
Good attribute. It would have to be somehow. And where is that returned? It's part of the pattern. Look here, attributes. Yeah. It's me not finding a better name. Get attribute state. Like when you don't know what else to use state. If the name is already in the module, then state is the last thing you can do, or data, right? Get attribute data. Get attribute state. But get attribute state is already taken, so get attribute, like this is more like an attribute value, but then you have value, right? This is so difficult to name. It's the most complicated thing here. State is gone, so get attribute
value data.
Value data, name data, assignment. But assignment is also taken already. So look at this. Name an attribute and describe its assigned state. So where is this used, the assignment? Because that is kind of the same, but with proper, right?
Assigned state.
It's part of the match group. So you have the same idea that I have? Like this I seem to be wanting. This assignment I want for this. That's how it feels. Or the other way around. This I want to be that. And then the question is, compact string. The name of the attribute has to be UTF-8. We know that because there is limitations to that. So a compact string or something similar is fine for that. So yeah, to me it looks like this assignment is actually the type that we would want for this. And
surprisingly similar, yeah.
Yes. And then you also have having these tuples, it's always making it a bit harder to know what's actually going on here. What is this? Whereas here it's pretty clear. So it's like this good attribute name can be literally a name. This can be a type type definition that can just be compact string or something, so that or a new type. No, it can be a new type, so that it's always validated. Yeah, something like that it could be. But I think that's it then.
Trying to consolidate those two basically.
Yeah. So there's this concept of new type, right? So you really just wrap something around. Represents a validated attribute name. And you can only create this after validating the input string. And internally, of course, you can say pub create. And now, you know, trusted code in this crate can just make these. And we know that it's going to be correct.
It's always going to work.
And the B string here, we have a compact. This probably has a... Yeah, so if you wanted to have something similar, it's probably a string now, because this is known to be UTF-8. And we have the state ref. And
that would be then an assignment ref, right? Instead of name ref. Or
yes. Yeah. Yes, let's rename it right away. Okay. And this one is a name. No, wait. Yeah, this is still an assignment ref. But then it would also look different. Then it would be more like this. So it has fields. And these fields are fine because they are validated, both of them. Even though this would now be a name, because it needs to be validated, but it's the same thing still. And that's an assignment ref. Yeah. Now we actually need a name ref, you know? Because otherwise we don't have a validated version of this one. So assignment ref we can't have. But this is ref business, yeah? Where is this used? It's used here to return or to provide, yeah, it is used here internally. Jeez. I think something went wrong with the names somehow. And then there was some confusion about the types and where and how they're used. Oh. So yeah, consolidate. This is probably a bit of a, you know, like this kind of struggle that you would have to go through to do this. I think it's manageable for one, because these crates are relatively small. And secondly, I think it's something to, you know, I think it's a learning experience worth having. And I don't mean this in a, I don't want to do this kind of way. I'm more like, okay, I'm happily doing this, you know, get out of presentation mode and see a bit more what's going on here. And then it should be fine. It's not a big deal, for sure. But I think it's something you can do and you will be better off afterwards. Yeah. Also about, you know,
absolutely,
like getting the view for this, like kind of right now it seems both you and I, we are trusting this. You know, this also went through my review multiple times. But ideally it doesn't, neither through my review nor through your review, because you kind of see this and, you know, look around, so to say. And I know how it is. Sometimes you focus only on these few things that matter and everything else is staying untouched. That's usually fine. But I think it's better to have this bigger perspective and take the time to have it as well.
Absolutely.
And yeah, now you will get the bigger perspective, I guess. Let's copy this patch and just put it here. Yeah, so I think this is the session notes for today, not looking into much more actually, which is a bit sad. I think it's worth to come to an end this time. In order to apply this patch, by the way, you just copy it. And then you say, oh yeah, let me clear this. Then you paste it into patch and say P1. And now it's assigned again.
Okay.
And yeah, there's this issue with it unexpectedly ends in the middle of the line. I don't know what that's supposed to be, but everything else worked. So yeah. First time that a patch that you just copy doesn't apply cleanly. Seems strange. But yeah. Easy as that. Oh, yeah, I would have wished, and maybe the pathspec is now okay. It really should. Oh yeah, and the cow business, huh? Originally we did that, so we don't want to use cow.
So we just go back to
we're on. So actually this unescapes attributes and values, and then we parse it, and then we create individual names from that. So still
so it would be an extra copy.
Yes, so we still save an extra copy, and that's fine. So never mind. So I was wrong. This vec here changes everything. So I was superficial there and fell for it. So that's good. All good. Should stay that way because it doesn't do unnecessary copies. There. And yeah, what about the prefix before we end?
Yeah, I think that is something to do with the matching. I checked it in the code and I could trace it back to something that gets piped into the top level commands, like, I don't know, git ls files or git add or git checkout or whatever, and they all take a prefix, and that somehow plays a role in the pathspec. And yeah, there is something going on there, but I couldn't figure out what it actually does. And I think it has something to do with something with paths, like I think it's a path prefix. So if you do something like git ls files in a subfolder, it's something to do with being more efficient and not like only searching the subfolder paths. But I couldn't really see how this is related to how you would use this specifically in a pathspec. And I think this is something that just goes on behind the scenes.
But it's still part of the pathspec. I mean, for going on behind the scenes, you write it into the pathspec.
But I'm not sure if that would be a user-specific thing. I mean, you definitely can, but I don't think a user ever has to do this kind of stuff.
So that this is something that Git itself does, you mean?
Yeah.
Yeah. It's a bit hard to see even what it does to me, to the untrained eye and pointer. So maybe the end, look, it doesn't do anything with that. Prefix lang. There's something it sets, okay, and then where does that go?
So I think if you look for something like command ls files in the file structure of Git, you can trace it back from the other way, and it's a little bit easier to see.
Command prefix here.
Yeah, and this at some point actually gets passed into the parse pathspec file, and I don't really understand what it is.
Okay. Okay, so yeah, I mean, maybe if consulting the pathspec docs, which I now can't Google, then
I did check that, and there was not really a mention of prefix in there at all.
Let's kill it then. Let's kill the prefix and get to it when we get to it. Remove prefix related code. And then
how would I remove it? Like, is it to just put a to-do in, or panic, or not implemented, or something like that?
Completely remove it. Like, it's not existing as far as we are concerned, because it's not part of the it's not part of the spec either. If you can't find it, it's not documented, then it's some internal stuff, and maybe we get to it. I know that there's a prefix. The prefix in Git for each command is the subdirectory relative to the root of the repository. And this prefix stuff is something that I already handle in some places in order to do, to give you the right path relative to where you are and stuff like that.
Mhm.
And that's just something that is, wait, where is it? Git pathspec. Not this one. This one. Git pathspec, of course. Here, apply prefix. And this just, treats the prefix as relative, or treats the path spec itself as relative to the prefix. And with that, you get a path spec that is relative to the root of the repository as opposed to relative to your current working directory.
Yeah.
And that's all. And maybe that prefix parsing that happens there is related to them passing the prefix in some special internal way, and then they parse it back somehow. And I don't know why you would need that, but it's something we can learn ourselves once we get there, and then it probably becomes more obvious. Yeah. So let's ignore that.
Okay.
But this is it. This is what, I call it prefix here as well for a reason, because I researched that once and it's literally just that. So here, prefix is git config now. And
yeah,
that's all. Cool.
That does make sense. I just don't understand why it has to be passed into the parser.
Yeah.
Yeah. Never mind.
Never mind.
I think it's probably related to matching more than to anything else.
Matching is going to be fun, but for another day. And I think that concludes it. So the hardest thing is the assignment refactoring. Mm-hmm. And that's probably also not too hard either. Cool. Then that's our today's session. Not the last one, but the one before the last one. Thanks a lot.
Hopefully.
And
thank you very much.
Thanks for watching. See you next time. Bye-bye.
Bye.